Good morning, all. Thanks for joining, maybe that early or that late for some people. Thinking about Jeff now. So I'm Sebastian Eggermont. I'm located in Brussels, in Belgium. Who am I in the, let's say, day-to-day life or during the week? I work in the chemical industry. But today, so I'm here as, let's say, hobbyist, chairing this Commodore User Europe session. We have a nice agenda for the day with some really good quality content, I would say. I see that we have currently 21 people in this room and only 2 attending the Facebook Live, but I know that that should increase because I received in the last 2-3 days, I received really a lot of questions. When does it start? How do we do to connect? Blah blah blah. So that's why I posted the links there. The idea to organize this kind of series of meeting came from the inspiration from the Toronto Pet User Group. I don't know if you are aware of that, but there is a nice user group in Toronto that exists for more than 20 years, I think, and they organize a monthly meeting, so they have enough content to share on a monthly basis. I think here our objective is to have something more on a quarterly basis, depending on the type of content, and on also it's a lot depending of you, of course. If you guys come and propose topics to present, also don't be shy to present the project you're working on. Encourage other people to do so as well. I think these meetings are really by the community for the community. So it's in terms of content, we are open to really not only programming. Of course, programming is one of the main topic. We are users, not just collectors. I think that's the main difference between this user group and other groups that you can find on the internet, where people say, "Oh, look, I find this nice Commodore 16 for, I don't know, 100 euros or whatever." Here, the focus is really on what we do with these machines. Be it programming new libraries, new games, tools that we use for programming, maybe hardware as well. I see a lot of things happening in the hardware scene, where we have these kind of connectors based on Raspberry Pi and these kind of things, new Wi-Fi modems, people developing new terminals today, like terminal software. But we are also open to magazines. There's also, I see, maybe it's due to the confinement, but we see a lot of retro type of magazines popping up here and there. Not only Commodore, but Commodore. I'm thinking about this 364, which is a really nice one, based on mainly focusing on games, but also on the Amiga scene. There's a lot of things there. BBS, it's sometimes difficult to find BBS that are still responding, but when you find some, it's of course always nice. So all Commodore machines really, Commodore computers, I would say. We are not talking about calculators or whatever, but whatever is computer machines are welcome here. Also related machines in the Commodore sphere, I would say. So like the Mega 65, we have the chance to get the colleagues, let's say, from the Mega 65 coming and present today. That's really nice from them to come here. But I'm thinking also about, yes, as I said before, these new Wi-Fi modems or whatever board, even if you are developing this, or you are using or testing things like the Ultimate 64, these kind of things. Welcome to join with these topics. I will tell more about the event itself and then the upcoming events at the end of the event. So around 12 or 10 past 12 or something like that. We try to keep the timeline, of course. I ask all the speakers to stick to their allowed time. But of course, this is a user group. Right? It's not a commercial presentation or whatever. So if there are some questions and answers takes a bit more than 2 minutes, I hope that we are all okay to stay a bit longer. I would say now it's time to pass to Jeff from C64 list. Jeff, are you with us? Can you unmute yourself? And if you want to share, then I will stop sharing actually.
Okay. Yeah, I have something to share.
I have a question. Can we stop the speaker from time to time and ask a question, or should we have questions after the speaker has finished this?
If you can type your questions in the chat box, I will look at these, and then and when the speaker has finished, then we can go to the questions.
Very good.
And we can ask to him directly. That's not an issue.
Okay.
Okay. Jeff, floor is yours.
Okay. Well, good morning. My name is Jeff Hoag, and I am from Portland, Oregon, USA. And let me give you a little bit of background on myself before I get started. So I started my career in programming way back in 6th grade on a TRS-80 Model 1. I used to go to the local Radio Shack and made friends with the salespeople, and just to sit there and type my programs in until my parents came and got me. Eventually, my school got a Commodore PET, and that's when I moved all my base of operations to the school computer room. And like a lot of you, I thought that computer games were pretty cool, so I decided to write my own, and I did, and that was my first project, really, of programming. Once the Commodore 64 came out, that was the love of my life, and we stayed together all the way from high school and into college. And then once college came, then I started getting more into more of the modern computers for business, and we eventually broke up, and that was really sad. But about 2002, I was on eBay and I saw a Commodore 64 for sale for 30 bucks. Imagine that these days. So I bought it and I started getting back into Commodore programming. But I had gotten kind of spoiled, let's say, with some of the more modern technology, and I decided to do some of the cross-platform programming rather than being confined just to the Commodore screen itself when I was programming. So I looked around for some tools to do that, and I didn't find anything that was really liked that much. So I decided to write my own, and that's why we're here. I came up with the C64 list. So let me go ahead and share my screen here. I have some slides. There we go. Can you see that now?
Yes.
I can see your screen. Yes, thank you.
Okay, great. All right, so yeah, 2003 is about when I started working on C64 list, and originally it was just a detokenizer tool, but I quickly learned that I needed to be able to tokenize back again in order to be able to run anything on the computer, so that came shortly after. And I decided that I would write it as a command line tool rather than a GUI, so that way people could use their own editors to edit and then run a quick tool to compile it into a PRG file or a D64 file, and then be able to run it on Vice or an actual C64. So once I had the basic stuff working, then I began to dream up a bunch of new features to put in. So I remembered all those times when I painstakingly had to renumber all of my programs, and so I decided I would go ahead and put a automatic renumbering in. And then I decided, you know what, I don't want to deal with line numbers at all. So I took out line numbers and started programming in a line numberless labeled BASIC. So C64 list can do all that stuff. Then I added things like rem removal, crunching the extra white space, and then uncrunching it, adding back white space to make it more readable. And then the ability to split projects into multiple files and use includes or uses directives to bring them in. Then I added conditional compiling and a whole bunch of other stuff. But BASIC was all fun and everything, but what I really liked to do back in the day was to program an assembly code. So the next big undertaking I took was to add a 6502 symbolic assembler and disassembler. And one of the things that I always wanted to be able to do was to be able to put BASIC and assembly code, machine code in the same PRG file, instead of having to go through that whole load another program thing. So I added that into C64 list.
We just lost you.
Yes. I was just wondering if that was an open question or and then I noticed we lost Jeff. I'm trying to contact him now. Yes. I think now he noticed, Bory. That
Did I drop?
Yes, exactly. Yes.
Okay. All right.
Welcome back.
Okay. I'm not sure what you guys saw last.
You were talking about when you started assembly.
Okay.
And the page that was showed was the one assembler, symbolic
Okay.
assembler, natively, blah, blah.
Sure. Let me move back a little bit here. Not sure what happened. All right. So yeah. So I released the assembler in 2012 in version 3.0.
You're not sharing anymore if you want
I'm
to
not
share.
sharing. Oh,
No.
okay. Sure. Let me. Okay. What's going on here?
You should not use an old Amiga to join these meetings. Yeah.
Okay. Let me try this again.
Yeah. Yes. We're back.
Okay. Okay. Can you see it now?
I can see. Yes.
Okay. Great. Okay. All right. So yeah. So let's see. Find out where I was here. Yeah. So I eventually started outgrowing the version 3 code base because what was really efficient for tokenizing and detokenizing BASIC, it wasn't really great for the assembler part, and it was really difficult to maintain and develop new features in. So I started a new rewrite, and this time I started just with the assembler. And this developed into a tool I called CHASM, short for C64 assembler. And this took several years, mostly because I was busy with other things in life. But while it was still under development, but usable, I used C64 List 3 for all my basic development, and then used CHASM for all my assembly work, and then combined the two outputs. And it was obviously not ideal, but I always considered that as a temporary solution. But last January, I finally finished that rewrite, and I got everything all compiled back into the C64 list and released it as 4.0. I also ended up rewriting a lot of the basic handling from the ground up as well. So the resulting code base is way easier to maintain and develop, and working in C64 list 4 is a much richer experience. So I highly recommend updating to C64 list 4 if you haven't done that yet. If you want to download it, you can go to my Facebook page, and it's just Facebook/C64 list, and there are links there to the latest releases. I also have a discussion page, which is linked from that page as well, where you can discuss C64 related things and ask questions, discuss projects you're working on and whatnot. So when I was writing 4.0, I tried to make it as compatible with 3.0 as I possibly could. So most of your source code is just going to move right over into C64 list 4.0 and 4.04. Second here. So one of the things that you might run into, though, is if you have some complex equations in assembly. Version 3.0, algebraic expressions were evaluated strictly left to right, and version 4, I updated it to use algebraic precedence, so my math teacher wouldn't cringe anymore. But most assembly code is simple enough that you probably won't run into that, but if you have more complex expressions, you probably want to take another look. One of the other new things that I have is the string engine. So in C64 list 3, the print statements were really cool because you could use these different codes that you can read and edit, but it didn't work anywhere else. So I went ahead and rewrote all that stuff so that print statements, data statements work, ASCII in assembler, and even characters in assembler will be able to understand the different characters, like yellow or red or whatever. So that is a lot nicer there. I also have more string conversion options. So I used to use alpha invert, but that was kind of wonky. So I added some new things. I added the lazy, which is for the standard character set. All your characters are converted to uppercase Patsky. There's also alt mode for upper or for a mixed case. So it'll convert the upper and lower case as you type them. There's also poke mode, which will convert the characters to the poke characters, poke codes, that is, so that you can write directly to the screen. And then I have some other modes as well that are probably less used. I have some, I added some directives. So instead of having to remember one particular way of writing these codes, then there are multiple ways. So hopefully they're a little bit easier to remember and a little easier to hit if you can't remember exactly what it is. So also there, C64 list 4 recognizes extensions, the .bas for basic. It also still recognizes .txt and .lbl if you want to use those. For assembly, it now recognizes .asm for assembly code, and also .sim if you want to import symbols from somewhere else. So if you are using the ASM or SIM files, you don't need to put the ASM and ASM directives around that code, because C64 list knows and will automatically switch into assembler mode for those. I also added different symbol levels. So instead of just having general symbols like C64 list 3, there's also local and important. So local labels are prefixed with an @ symbol, and you can reuse the name as many times as you want to. I also added something called important symbols, and by adding an exclamation in front, exclamation point in front of the name, it labels it as an important label, and those 3 levels help sort out some of the labels that you see in the dot symbol output. So if you don't want to see all your labels, you can mark just some as important and only see those ones come out. I also have anonymous labels, which are essentially just local labels without a name. It's just the @ symbol. And also I have something called symbol demotion, which if you're developing something with important symbols and then you use that file in another program and they're not that important anymore, instead of having to go change all those symbols, you can just demote them to general. So it all helps kind of manage your symbol table. And I'm almost done here. I have some new pseudo ops. A couple things that are cool are the adder check, which helps you figure out how much memory you're using. And then there's the data pseudo op, as opposed to the byte and word pseudo ops that allow you to add only 8-bit or 16-bit values. The data will allow you to add 8 or 16-bit values in any order that you want. Then there's like bits, which helps you create bitmaps, and then embed, which will allow you to embed a binary file in your code. I have parser variables, which are user definable, and then there's also some built-in ones that help you do revision monitoring, like build revisions, date, time, and a random ID for that is randomized every time you build. There's some new directives that support that stuff, as well as some conversions. There's also a tick, which if you want to comment out a directive, just put a tick at the beginning and it won't recognize it anymore. It won't cause an error either. There's also super variables, which were actually introduced in C64 list 3, but I didn't publicize them very much. Now I am. And essentially what that does is it allows you to use long variable names. And then it can automatically convert existing code to use the super variable names as well. And that is pretty much the end there of my presentation. If you want more information, please download C64 list and look at the user's guide, and there's a lot more information there. You can get a hold of me at c64list@gmail.com or on my Facebook page. So thank you very much.
Thanks, Jeff. I see we are already a bit killing the the time. But
oh no, sorry about that.
I see 3 very interesting topics, questions here.
Okay.
First of all, do you have other plans to support do you have plans to support other Commodore 8-bit machines with C64 lists?
I don't specifically have plans for that. I think that it'll probably work for a lot of stuff. Like if you're interested in PET, a lot of it will move over, but I haven't specifically worked on that. If somebody's interested, yeah, we might be able to though.
Yeah, I see a question from Fabrizio there. Any support for basic 10-liners? That's generated shortest abbreviation and short possible code as a text file. That's actually, I think I contacted you 2 years ago or 3 years ago when I was actually participating to the 10-liners, and I had asked the same question.
Oh, okay,
if
right.
you remember that when you do like, for example, Hoag, that you can just type a PO.
Yeah.
So that it helps shrink a bit because the number of characters are quite.
The
Sure.
competition is ongoing right now.
Sorry?
Yeah, the
The
competition.
competition is for this year. Yes, indeed, it has.
Oh wow!
It has just started again. Yeah. So is this taken now in this version 4? Can I type PO for Hoag?
So I started that, but I didn't finish it because it was a little more complicated than I thought it was going to be. So there is some support, but it doesn't really work yet. That is something that I did plan on putting it in, but I wanted to get C64 list 4 out. So yeah, I'll get back to that though.
But now you know that there is some demand, and now you know why as well. Right? It's because of
right?
this coding competition. Very quickly, I'm sorry for the or colleagues waiting. Are special characters detokenized in a standard format? For example, PetCat, CBM Program Studio, and this kind of stuff.
What was the question then?
Maybe Fabrizio, you can.
Yeah, whether the way you detokenize the characters, is it portable to, for instance, CBM PRG Studio, or if you're detokenizing in the same format, that you could just copy paste.
Okay, so yeah, I haven't actually used CBM Studio. I downloaded it once and I was looking at it, but since I have C64 lists, I haven't really used it. I don't think that they're exactly the same, but it would be interesting. I don't think it would probably take that much work to make them compatible. Yeah,
I'm telling you this because I had to adapt some programs, and it's painful procedure if you have to do it for hundreds of characters.
Right.
Yeah, so it is nice if you could. Maybe you already do, but by chance you are using the same names, because some of the names are obvious, like like the colors. Right. So maybe there is a little effort on your side, and will make it easier for other people to use your in conjunction with other tools. Yeah. So if you get a chance, and if you have that information, if you could send it to me, I would be interested in seeing that and I don't have a complete list, but we can try to figure it out maybe, but I don't have to. Okay. Yeah.
Looking at the time, I suggest that we make the transition to the next speaker. Maybe Jeff, if you, I know it's late on your end, but maybe you can if you can still stay a few minutes, you can answer in the chat. Yeah, I'll stick around for a while. To the friends in there, and then I will make the nice transition also to Mega65, who our next speaker, if I'm not wrong, because I saw that I downloaded the manual, and I saw that C64 list was referred actually in one of the manuals from Mega65. So oh really? Okay. It's nice for you to hear if you didn't see that. And maybe with this word, I can welcome then Martin. So Jeff, if you can stop sharing, maybe. Okay. And I think we have Martin and Detlef. I don't know if I pronounce the right way.
It's okay, Detlef. Yes,
Detlef.
Thank you.
Perfect.
Yeah,
thanks.
First of all, please. Thank you for introducing C64 list. It's a very interesting project, and I think you would maybe like to look into making a C65 list or Mega65 list at some point, but we can talk about this later. Yeah. So we're gonna rush very quickly through the history of our project, which is called Mega65. And today, Martin, who is our social media expert, and he's also CFO of our little company we had to found because we are moving bigger funds today. So we have to, because the project got really big, and we're doing this for almost 6 years now. And myself, I'm leading I'm doing the management for the whole project since 2015, and not so much coding, unfortunately. So Martin, if you can just put on those slides we produced, we're gonna rush very quickly through it. So this is a Mega 65, to be exact. This is the pre-series, which is not the current state, but it's the best photo we got of it currently. Next, please. And so the quick history, you probably know it all, the famous 18-bit machines. In 1991, there was this Commodore 65 prototype, not released, but sold off, and the project was stopped because Commodore bought the Amiga, and they said everything has got to be 16-bit, and they don't want to sabotage the release of the Amiga. So the project Commodore 65 was stopped, and the prototypes were sold off, which is nice to see. It's about 30 years now, or exactly 30 years. Next, please. And yeah, this was the first iterations when we started. We worked with the Nexus 4 DDR boards, which is now the current version is called A7, and you can get those for around 100 euros, I think, and they are still capable to run the Mega 65 core, and we are still producing bit streams for those. And this was the first own board we made, and it has some flaws. For example, you see the SD card slot was forgotten. We put that on afterwards. We showed this, I think, in 2006 at break 16 at a revision in Saarbrücken, and some stuff on it, but only for those interested in private. And the next board is the okay, we made for the Amiga 30, we made this laser Sintret first prototype. It has the Nexus board inside and an additional small PCB. And quickly afterwards, not so quickly, I think in 2017, we had the pre-series, and this is the R2 board. This was inside the case you saw at the beginning. It also already has its own board design with everything on it, and it's not very far from what we got today. And this is the latest board, the R3. It's inside the dev kits we released. We sold 100 dev kits last year. Fortunately, mainly to developers who are currently doing software on it, which I will show later. And this is the dev kit. Since our injection molds were not ready, we had a cooperation with Plexi Laser, who does those nice plexi or acrylic glass cases for the Amiga and the C64, and he made this especially for the Mega 65 dev kit. So there are only 100 of those out in the wild, and it's a rare collector's item, but fortunately used by people actually developing on it. This is Anton, who is also lurking here, and this is the video we made how to assemble the dev kit, and I think it's a very nice shot, so we put it in here. The keyboard, which is kind of famous, maybe you can skip to Shallon praising it. So this is the back side. Actually, the keyboard is very expensive, but we didn't want to make any compromises on that. That's here, Shallon.
I keep feeling the keys depressed, and it feels so good. I mean, the company that made these is really good. I would trust them to make a keyboard any day.
Okay, so this was one of our biggest concerns. Thanks, Martin.
It just feels so nice.
Yes, and it's very expensive, and it's Cherry MX based, and it has a metal plate underneath, and we put some specials on it. All the LEDs are double RGB LEDs, freely programmable. In fact, it's also an FPGA inside this keyboard, so no ARM, no proper, no closed source things inside the keyboard. And there are more goodies, the lock keys, they are extra clicky and stuff like that. Yeah, please, let's go on. And about the injection molds, which are finished today, this was also quite a process with Hinsteiner in Austria. We did a few iterations, and yes, now let me switch it. My arm is falling off. Okay, this worked. We now have the final injection molds, and I will later show you on this wacky live cam the case, what it's today, and it's really, really good. It's industrial quality. Yes, we work towards this with the community. This is the 3D model. You can see what we've done in the back. If you wonder why these ports are not used, actually there's no PCB at these places. You can, we call these breakout ports. You can do extra ports like user ports if you want. Someone will probably develop small PCBs for it, but they are not in by default. This were also wishes by the community. Quick look at the manual. It's available. We build it like weekly as a PDF. It has almost 1,000 pages already. We're going to split this in different books because there's everything inside, how the Mega works, about basic 10, how you program the FPGAs. We have 3 FPGAs total, 1 in the keyboard, 2 on the machine for several reasons. It's quite a complicated machine, but it just can do so much that we are happy with what we got. Right? Okay, so this is the emulator. LGB does the emulator XEMU, and it does C65 original emulation, but also Mega 65, and it's really good. And people are developing software on it, which actually also runs on the hardware, so very helpful. Just a quick view. I mean, this is the Commodore users meeting, and we still dare to show some spectrum because, yeah, there are other cores, of course, developed for the Mega 65, and since you have a real case, you have a real floppy drive, you have a real keyboard, it absolutely makes sense to us to port other computers like Amiga, Atari ST, etc. And this is the Spectrum core, which the ZX Uno is based on the ZX Uno, which is very capable and very much fun if you dare to look at something as yeah, the most common question for a few years. We decided not to let the community rush ourselves because we are nerds. We don't want to earn any money from it. Mega is a non-profit organization, and we are not. We don't want to get any money out of it. We just want to make the best, most nerdish product for ourselves and everybody who wants to join. And I think so far we've succeeded in it. So we did not do any Kickstarter, etc. We did some fundraising, but very differently for the molds. And we will see the names are inside the case, etc. So it's in very close connection to the community. It's getting built slowly, and we are now at, let's say, 90–95%. So at this point, maybe I can, because we were asked to actually show what's the current status. So I'm trying to, yes, switch the camera and do some live action and show you the machine. Of course, it's very nice. The keyboard is not the latest. I don't have the latest myself. They all went to the developers. It's the printed version. The current one has a double shot injection keys, so you're never gonna rub off the chars, etc. So let me just open that. If it's too quick, I am too quick. It's too wacky or anything, just let me know. So
you're a bit focusing on the left part, actually. If you can
yes,
a
okay.
bit. Yes, thank you.
It will be more complicated to show you something on screen, hold the camera, etc. But okay, I don't know if you can see it. Yeah, the names of the guys that probably not enough light, but as you can see, machine is running. Here's the FPGA programming adapter, which is no longer needed because the machine can flash itself. But yeah, since I'm testing always the latest bit streams, it's quicker for me to do. So let me reset this. You see it resets very quickly. We can set it in a mode where it's just like a real Commodore. It takes like 1 second with black screen, but this was the debug boot. So we added, you see these nice raster line effects now, which also can be switched off, CET emulation. You can also see the new text on the basic, because what we tried to is we wanted to continue where Commodore left off the machine, and this was not only the PCB and some problems still existing with the chips, but it was also the basic. The basic 10 was not finished, and we started finishing it and removed all the bugs and added the missing functions. And so now we added our name, or Mega. Let me switch again, sorry for that, to the copyright screen. It's nice to be besides Commodore and Microsoft, and it's also very nice to see the span from 2021 to 1977. It's quite some time spent. So yeah, let me show you something. I am going to show you stuff from Shellen50K. Maybe you know his Twitch channel. He's constantly doing programming for C64, now Mega 65, and for Game Boy. And I urged him to release what he did here, a small tech demo, because due to copyright reasons, we could not, we will not release it as a full game, but just to see the capabilities. I'm probably not able to hold the camera and play properly, but this is a tech demo. We just made a Turrican in a few days, and yeah, as you can see, it's for an 8-bit machine. It's very, very capable. And to tell the truth, he's not happy with the engine anymore. He said the parallax lux doesn't work and stuff like that. He did a much better one. So I said, please release it as a tech demo so people can see it. Okay, but now back to Basic 10. I'm going to show you some more things. Shellen did a basic competition, and just so you see, okay, maybe I have to add, the machine is running at 40 megahertz. So you can switch to 3.5, make it like the original C65, and it's very much compatible to the C65. It's also getting more and more compatible to the C64. I can also show you if you have to turn something on that. But now it just, I want to show you what's happening in BASIC. So Shellen did this BASIC competition. And you see someone, for example, coded Tetris in pure BASIC with some reflections. Here, I'm going to try to get rid of those. And it even has music. And now I will try to play while holding the camera, just so you see. Oh, no, I want to continue. So this is pure BASIC, and I think it's easy to notice the speed. You can now really make nice games in BASIC, and they feel like real games. It's not something slow or wacky like it was before. And yeah, this is a nice example. I really like to play this a lot, and again, it's pure BASIC, which I will show you in a second. Let me just put that tile there. So okay, and if I hit run stop, you see here that it's pure BASIC. So I don't have two hands to hit run stop restore. We're gonna live with this. And what I also want to show you, that the BASIC now got syntax highlighting, which BitShifter added among a lot of other features. And we're trying to do this, of course, very much in the style of Commodore, and not to sacrifice the style of programming and the feel. But we also want to give you the same amazement as you had it in 1983 and 1984 when you discovered your first C64. So in fact, we have to do a lot of things much better, because if you nowadays, if you type on your C64, it does not feel as great as it did when you were a child. But so we have to do the best possible keyboard to give you the same feeling you had when you were young. And we're trying to do this with all the stuff, with the machine itself, with the basic, with everything. And yeah, it seems we are succeeding with it, because people are more and more coding software for it, and they're enjoying it. And of course, everybody's waiting for the first iteration of real computers, not the dev kits, which is, and this is maybe an exclusive to say here today, we're working really hard on releasing it, the first bunch, which is planned to be 400 machines in this year. We will at least give you the possibility to pre-order, to put your name on the list that definitely will get the machine within this year. With a little luck, it will be under the Christmas tree for 400 people this year. So I think this was quite a rush, but now I'm open to questions, which I haven't looked at the chat, but it seems to be quite full. So maybe if you want to moderate the questions, that would be helpful.
Yes, there are some actually. Let me see from the start. There's a comment or question from Antonio actually. So he has had the chance to play with the Mega 65. He says, one thing I'm missing though is support for safe illegal opcodes. Is that coming at some point?
Okay, so the spirit of the C65 was that all the illegal, or let's say unused opcodes, were filled with new opcodes that really were helpful. And of course, we are always, we're not sure at what point we want to do support the illegal opcodes, because this pretty much sacrifices the original idea of the C65. But with the development of FPGAs or VHDL cores, we are getting very close to having C64 ported from MiSTer, for example. So at this point, we can of course say, if you really want to do so, you can just run the C64 core. We could of course also switch to the C64 core without you knowing it, or when you make the Go 64 command. But honestly, I wouldn't do that, because if you want to use your Mega 65 just to play C64 things, you can do this with a C64 core, I think, and somebody will make that and convert it. And we're already helping in getting an environment where you can just drop the MiSTer cores into, and you get the Mega 65 bit stream out of it. For our main core, I think it's not the right way to support the illegal opcodes, because this would mean in C64 mode, which is it's a seamless. You have 3 levels. It's C64, C65, and Mega 65. But you can do anything from every level. So you can do from C64, you can switch to 40 megahertz. And this is where you actually start. You take your C64 code. I took my raster code, which was like 30 years old, and I just put it, I ran it in the C64 mode. Then I switched to 40 megahertz, and I had just so much more time to do with the same code, just a lot of things more. And it's very natural that you will start using the new opcodes. All the area is filled with new clever opcodes from the 4510 CPU, and you want to use those. And so I think in the Mega Core you won't ever have illegal opcodes. If you have stuff like old crunchers that actually rely on that, you will switch to a C64 core. Otherwise, I think the new opcodes you get with the 4510 10 CPU are much better than the illegal opcodes we had on the C64. I hope this was not too complicated and answers.
I guess you answered the question indeed. Just looking at the time, I see that Martin is also in the background answering some questions directly in the chat. Maybe we can take these quickly, these two. First, from Fabrizio, which development kits supports the Mega 65, C65? Any support in CC65 in the future?
This is, I didn't quite get it. I mean, CC65, the C compiler, actually supports the Mega 65. This is one question. We have another C compiler which is about to be released from Volker Bartelmann, is VBCC. It's very much optimized. A bit shifter who's working on the ROM actually wants to do a real-time C interpreter, and this is for the C compiler stuff. And regarding platform, hardware platforms that actually can run it are the Nexus board, which you can buy or freely buy, the A7 board, and of course our own main boards. And yeah, these are the platforms you can run on. There's one guy on Discord. I also, if you're interested more, please head to mega65.org, and in the top menu there are all the links to the GitHub and to the manual and to Discord. And there's a lot happening on Discord. There's one guy who has, I didn't quite get it, to be honest, a small FPGA board with an RTX 7 on it, and excuse me, 100T. It's the 100T or 200T, which is on the R3 board, and he's doing his own board which can run Mega 65. But I'm not, I don't know any details about that.
I'm not so sure that C65 fully support the Mega 65 at the moment. I think the assembler is supported. C code, I'm not so sure it supports everything. I think
right.
Yeah.
You're right. Yes.
I see again some. Maybe we can indeed continue on the also on the chat box. Maybe the last one, because even you mentioned that that it will be available. Hopefully by end of year, etc. I see a question related that many people are asking, I guess, when will you start taking orders? With that one, I will stop the recording and preparing for the next, please.
We're hoping to start the pre-orders in summer, maybe in summer, yeah, or early autumn, maybe September, or yeah, around September, I would say we start the pre-order phase.
Pretty good. Thanks a lot.
Thank you.
Again, if more questions coming, if you can be so kind to just answer them directly from the chat, that would be nice. Otherwise, we are just killing the the time for today. I see we are already more than 10 minutes past. Thanks a lot, and I will do the transition then to Michal. Actually, Michal has recorded also a nice video of himself talking, but he will be available after. He is already in the call, I saw. So if you can stop maybe sharing, and then I will start sharing my screen, and I will run the video of Michal on running MS-DOS on an 8-bit computer. So I go for sharing of my screen. I hope someone can confirm you see my screen. And then when I launch the video, I hope someone can confirm that you are hearing the sound from the video. First of all, can you see my screen?
We can see your screen.
Yes.
Yes, we can see.
Affirmative.
And now, a terrible moment when you see this little Windows bubble running. What's going on? Oh. It did work during the week. It did late at night when there was nobody connecting to the meeting. I have tried that, but maybe having this Zoom client installed at the same time. That maybe doesn't work. Michal, I know you're in the call. Maybe you could try to run it from your end and share your screen if you don't mind.
Yes, I just need to get the hard drive with it. Okay, so just a minute.
Okay, you don't have it.
I don't have it on this computer. I have it on the other one that I use for video editing. So I just go and fetch the hard drive.
It's like on TV, you know, when you're live, there's always something like just before, I think the minute before I started the live thing, I came with my fresh coffee just made, and of course I pour it all over the table. And my colleagues know that I'm quite used to these kind of things, you know. And it's typical me entering into a meeting room with my fresh coffee, very hot, and just pour it everywhere, and it's just a nightmare. So, but okay, that's the live.
It's okay to hit others. Never ever hit your hardware.
Indeed. I can stop sharing here. Maybe I could also try actually to, because I have another computer running next to me. And there it says your tab just crashed. Okay, good. There is maybe some kind of magnetic attack on this house today. Michal started sharing. Excellent. A lot of videos of Michal there. Yeah, that's the one. But we don't have the sound. Maybe you need to do something.
Yeah, in the sharing view, you can say share a sound in the. You should have a little bar, and there's 3 dots to the right, and if you click on them, then you have like share sound from your computer.
Hi, my name is Michal Pleban, and I would like to show you how to run MS-DOS on this Commodore computer.
Perfect, we have the sound. Thanks.
Some of you may recognize it as the CBM2, the business computer that Commodore introduced in 1982 as a successor to the Commodore PET. It has several improvements over the PET, for example 2 MHz system clock and 256 kilobytes of memory, which is quite a lot for a 6502 system. It has even a C chip, which will become handy just in a few minutes. But unfortunately for Commodore, a few months earlier, IBM introduced the PC, a 16-bit system which ran MS-DOS. And for a while, everybody thought that MS-DOS is going to become the new standard in business computing, just like CP/M was before. And like CP/M, you could adapt MS-DOS to your specific hardware architecture just by replacing the I/O functions. And this way, a lot of different MS-DOS compatible computers appeared on the market, just like the Digital Equipment Rainbow or Victor 9000, which was designed by Chuck Peddle. Some Commodore wanted to join this market too, and that's what they came up with. This is an Intel 8088 processor card for the CBM2. With it, you can create a dual processor system, or actually even a triple processor system, because you can also install the 8087 math core processor. Those processors work together. There is an arbitration mechanism which determines which processor can access the main memory. There is a communication mechanism, so the CPUs can pass messages to each other, and the messages can be passed both ways. So you can have an application working on the Intel processor calling the 6502 to perform some kind of I/O, because only 6502 can have access to the keyboard, screen, or disk. But you can also have an application such as a spreadsheet working on the 6502 and calling the Intel processor to perform some calculations, because it's faster. So that's quite a fascinating hardware architecture, and Commodore adapted MS-DOS 1.25 to it. So basically, you could run MS-DOS on it, but the problem is you couldn't run any applications. Because the applications written for the PC usually used several distinct hardware features of the PC, such as the video memory, the memory layout, the specific I/O devices, because there was no API in MS-DOS to use them. So even if it's MS-DOS compatible, but it's not PC compatible, you cannot run any software. So those computers that were not PC compatible very quickly failed in the market. Unfortunately, that's also what happened with the CBM2. And that got me thinking, what would it require to make this very different hardware architecture PC compatible? And it turns out that you can achieve a very high degree of PC compatibility with software only, so without any kind of hardware modifications. And for that, you just need to do two things. First, to implement the PC BIOS interface, which means implementing interrupt 1.0 for screen access, interrupt 1.3 for disk access, interrupt 1.6 for keyboard access, and so on. So there's around 30 or 40 I/O functions that need to be present for the architecture to become PC compatible. That may seem a lot, but they're actually simple wrappers for the existing I/O functions that can be found in the kernel, just with the interface identical to the PC. And the second thing you need to do is to emulate the video memory, because most of the PC applications write to the video memory directly, because that's faster. So they expect the video memory to be located in a specific place in memory. So to perform the emulation, we just need to copy this memory location to the real video memory found on the 6502 side. And that can be done, for example, using a timer interrupt. And that's it. With those two things, which are a software-only solution, we can run not just MS-DOS, but a whole slew of PC applications such as Norton Commander, Turbo Pascal, VisiCalc, and so on. That's quite impressive in itself, but we can do even better. We can create virtual PC hardware, by which I mean software routines that make the architecture look like it has specific I/O peripherals, which it doesn't. And for that, we need some kind of virtualization environment. So how do we create a virtualization environment on the Intel 8080A processor? Well, it's simple. This is a virtualization environment. And it works by connecting the I/O access signal and the non-maskable interrupt signal, so that every time the software tries to access some I/O port, an interrupt is generated, and the interrupt routines performs whatever emulation is necessary to make the hardware look like it has this peripheral. So for example, we can emulate a very important part of the PC architecture, which is the PC speaker. The PC speaker uses two hardware ports, one for frequency of the sound and one for turning it on and off. So by intercepting accesses to those two I/O ports and redirecting them to appropriate seed registers, we can make the machine to emit sound, just as if it had the PC speaker. So in less than 50 lines of code, we can create a virtual PC speaker that works just like the original one. To use all of this, I created the replica of the original 8088 processor card, because the original card never made it into a production. So if you want to use some rare hardware, the best way is just to make a replica of it. And that's it, with some nice features added. So there's 1 megabyte of memory here. There is a memory card for storage. There is a real-time clock, which is battery backed, and so on. But in essence, it is the same hardware like the original. And you can even run the original MS-DOS 1.25 if you are so masochistic. But it can do also much more. And let's see what actually it can do. So the computer starts with Commodore Basic, just as if you would expect it to, but we can also switch it to the Intel side. Oh, there's a nice boot menu. So let's boot the computer and see what happens. Yes, it runs FreeDOS. So we can use not just some old versions of MS-DOS, but also a modern version of FreeDOS works as well. Huh. So what about Norton Commander? Does it work? Well, yes, it looks like it does. So what about this directory? Could it be Turbo Pascal maybe? Let's see if Turbo Pascal works. Just give it a few seconds. And yes, Turbo Pascal works perfectly. So maybe we could program some Pascal. That's a cute little Pascal program, which looks deceptively simple, but to actually make it work, there's a lot of magic that needs to happen. To make the delay work, there needs to be timer interrupt. To make the sound work, there needs to be the virtualization support. So let's see if it works. So as you can see, we have created a PC-compatible computer basically with a software-only solution. So I hope you enjoyed this presentation. Thanks for watching it. So if you want to find out more about the Intel 88 processor card or the PC compatibility software that I wrote, just check out my website, where you will find all the latest information about this project.
Excellent. Thanks a lot, Michal, for sharing. I saw some comments in also on Facebook. Apparently, there was some issues with the sync between the image and the sound, but after the first 5 minutes, I think it was okay. I'm trying to look if there are questions popping up in the chat. Really nice and clever approach. I don't see two new message. Michal, how is this different than the original board that Commodore created?
Okay, can you guys hear me? Because I had to unplug the microphone.
Yes, you're a bit far, but still okay.
Okay, so yeah, it is different in the sense that there's some additional hardware attached. So yeah, like I said, there is a memory card, for example, that was not present on the original card, of course. There's more memory because you really need 640 kilobytes to run MS-DOS programs. And there is some glue logic on the original board that is not necessary here anymore because it uses static RAM, so you don't need memory refresh and so on. And some glue logic was incorporated into the CPLD. This is the big square chip here in the middle. So that there's room to fit these boards into the low profile CBM2 computers. So basically it's an improved version of the original hardware, but it's compatible. So all the software that run on the original board will also run here. Yeah, hope that answers your question.
Yes, I guess so. So the software hooks you described run on that board, not on the CBM2. That's a follow-up question.
So I presume you mean the hardware virtualization thing. That so that yes, okay. So yes, that's only possible on this board because it has this additional connection to the non-maskable interrupt. So you can't run this part on the original board, but everything else is possible on the original board as well.
Okay. Good, thanks, Michal. I guess maybe you can also stay and look if there are new questions popping up in the chat. I'm looking at the time and I see we are accumulating, you know, the delay. So I will welcome now Fabrizio. Fabrizio,
Yes,
he more or
here
less
I am.
introduced his topic by asking already questions on CC 65 earlier, right, on the Megas. Fabrizio is going to tell us about the Cross-Lib, a universal 8-bit library. Fabrizio, the floor is yours.
Yep. I'm trying to share my screen. Let's see if
I
it
can see your
works.
screen. I can see
Can
your
you
screen.
see
Yes.
my screen?
We can see your screen. Yes.
Very good. I'm presenting here Cross-Lib, which is a project that has been ongoing for at least 3 years. It is on GitHub, and it's not only Commodore related, it is 8-bit related. It is, as you said, it's somehow related to CC65, but not only. So it's about the C language. It's about using the C language, the standard C language, to code games, little games, on things like the Commodore VIC-20 and any other 8-bit computer, including the arch enemy, the Sinclair Spectrum, and not only computers, but also game consoles, handout game consoles, and even exotic devices like scientific calculators or arcade boards or hacked toys that can run something. So it is the idea here is to cover nearly anything. So I define Cross-Lib as a universal retro hardware abstraction layer. What do I mean by this? So by abstraction layer, I mean something that hides details. So it's a library. Cross-Lib is a library, and it's supposed to hide some of the details of the specific machines. So it's a list of APIs you can use to code games. And by universal retro hardware, I mean that it's supposed to cover anything. So ideally, I want to cover any device, any possible feasible device that could run, and mostly vintage devices. I can even cover non-vintage devices, but the scope of the project is about 8-bit vintage computers, consoles, arcade boards, and so on. So to give you an idea of what it is, I can compare it to other projects that do something similar, but still I think that Cross-Lib is unique. Many other projects are unique, but in that I do things in a different way, and I have different goals. Similar looking projects are 8-bit Unity. I think some of you know about 8-bit Unity, which is a super cool project, which is a library that supports at least, I think, 5 different targets to code in C, in the C language, games. You can code games, and it has lots of features. And but it's only most 6502 based, so it depends on CC65. There are other dev kits that do something somehow similar, like Turbo Rascal Syntax Error, which is Pascal based. It's a dev kit, and Turbo Rascal is different in that it supports more targets, and but it's using the Pascal language, not the C language, and it has its own compiler. So Turbo Rascal is much more than just a library. Cross-Lib is Only a library. It's not a compiler. I depend on compilers. I depend on many compilers. Actually, I use a dozen different cross compilers. And I cover up to 200 different systems. I cover any, well, not any, but many exotic devices. And of course, I don't support all the super special effects you can do with the other tools. So I only support minimal graphics and sounds. But still, you can write games. I can show you some of the games I've written with my library. So this is just a table that shows some of the differences and some of the limits of the different dev kits. So the idea is that of Cross-Lib is that you write your game code once, only once. You never modify it again, and you compile it for 200 different systems. So you write only one game once, and you get 200 versions without modifying, without even adapting the code. Cross-Lib is supposed to produce 200 different versions of your game, even adapting to the different screen size, to different colors, to different features. It will produce the same game with the same sort of sounds, the same graphics, automatically. You get 200 versions for free. You write it once, you get 200 versions for free. How is this possible? Well, this is possible because the C language is a standard language, so all the logic can be done in C, and the C language is the same across all the cross compilers that are NCC compatible. So that part is done by the C cross compiler, not by me. I get this for free. The problem is that input output, sound, graphics, keyboard input, joystick input is different. There is no standard C library for that. So I had to implement this for 200 different systems. And so you basically, and I expose this in an abstract way. So I have done the work for you. You use my universal APIs, and you get a game that uses the joystick, the keyboard, and the sound capabilities of each system in a way which is somehow abstract. This is a little advertisement I'm doing on a related project. I have documented some of the tricks I use in C when I'm coding for 8-bit systems, computers and consoles, and I have put this on GitHub because when you try to code in C, even if you're not using Cross-Lib, this is independent of Cross-Lib. Of course, you cannot code in C as you would do on a real modern PC. You have to do some tricks, and I use many of these tricks in Cross-Lib, and I've collected some of these tips and tricks on my GitHub page. So if any of you is interested in this, you can take a look at this. As I have mentioned, so Cross-Lib is a library. You write your code with C and Cross-Lib, and you compile it with a dozen different cross compilers. It will always compile and produce the same game. So I have to support many cross compilers. So this is a partial list of the cross compilers I'm supporting. Of course, C65 to cover all MOS 6502 architectures. So all the 8-bit Commodores are supported by C65. For the Zilog 80, I'm using the Z8080DK dev kit, which has 2 different cross compilers. I support both of them. I use this also for the Commodore 128, because I can even produce a version of my games that run on the Commodore 128 in Zilog 80 mode, not CPM. It's mode 128, but in Zilog 80 mode. So I'm using the Zilog CPU if I want to, and I can do this exotic thing. I use CMOC for the Motorola 6809 architectures. I use LCC 1802 for some exotic computers and boards, like the 1802 boards that I use on some on the Voyager. So on some of the, so I could run my games in space. So some of these CPUs are used in were used by the NASA. And I support ACK for some other vintage, including vintage systems, like including the PDP, for instance. I support a XTC68 for the Sinclair QL, and lots of different GCC modded cross compilers that are based on GCC but have been modded to support vintage CPUs to cover many other systems. So as I mentioned, the list of targets that I support is very long, so I won't read these slides. These slides are only meant to impress you. So it's a long list. It's only a partial list. So, and there is very well-known computers like Apple II, for instance, all the Commodore 8-bits, all of them. And exotic stuff like the Comics 35 that is based on the 1802 CPU, the Coco computers, and Commodore 128 in different flavors, and lots of stuff, which I won't read here. And all sort of Eastern European computers that were only used there. I support lots of consoles, handheld consoles, scientific calculator like the Texas scientific calculators as well, and some more modern stuff. So I have some initial work for 16-bit architecture like the Atari ST, Sinclair QL, Amiga, and as well as native PC. I can compile my game on they would run on the PC natively. This is an example of a piece of code that would run on all the systems. You just write this. Well, there is some initialization which I'm not showing here. You run it through Cross-Lib. Cross-Lib will invoke a dozen different cross compilers, and you get 200 versions of this demo, which is the Matrix train from the movie The Matrix, which is using I'm reusing some of the tiles, some of the sprites I use in some of the games. So it will just look like the Matrix train. And this is, I think, here I'm showing the Atari 8-bit version. And this code looks like C, as you can see. There are some commands that have the _XL_ prefix. Those are Cross-Lib commands. All the rest is standard ANSI C. So you just that's the point of the Cross-Lib. You write it once, and you build it through Cross-Lib, and you get it for all of them. So how is this magic done? As I said, I had to do the hard work myself. I had to code the input and output for hundreds of different systems. So I have not done it really for 200 systems because some of the systems are similar. So I am not redoing the same thing multiple times, but I've done it many times. Okay, in order to cover all these systems, including very exotic ones. Then I am hiding this through some abstractions, some APIs, and I'm using macros, C macros, to do this sort of magic. So you use the macros, then the cross compiler will do some of the substitution, so that the compiler, well, in the end, the compiler only compiles the specific code for the specific machine. And for the graphics assets, for the graphics data, since these graphics data have to be passed to the linker in a way that they will be stored in specific memory location. This is not just C code. I had to do some meta programming. So some Python scripts will convert the data, the sprites, so to say, the tiles, in a way that they are adapted on the fly automatically to each system. So it looks like a little bit like this. You have some standard C APIs, so some C functions like the ones with the underscore XL underscore, which I showed before. The macros will do the magic to substitute them at the preprocessor level into, for instance, Commodore 64 code, C code, or ORIC, for instance, or Nintendo NES code. This is done by the preprocessor or by my makefile. They will just select different files. So this magic is done by either the preprocessor or the makefile that I use. And for the graphic assets, because graphics have to be, I only write it once. So I only define my sprites once, and then they have to be converted into something that the specific cross compiler for the specific target has to understand and has to put in the right memory location, for instance. And this is done by some Python scripts that I run when I do a build. So all of this is done automatically. So for you, you just run the build, and all of this adaptation is done magically. And so you get the same game on a Commodore 64, on an ORIC computer, or on the Nintendo NES game console. Of course, Cross-Lib has some limits. It's not meant to do super special effects. You won't use it to do games like PigQuest. You cannot do it in Cross-Lib. Cross-Lib is not meant to do super graphics and to exploit all the features of a specific system. It's not the common denominator. It's not the minimum common, because it's doing more than this, because Cross-Lib supports even systems that have no colors or no graphics at all. If there is no graphics, Cross-Lib will use ASCII characters. So the game will run even on a Commodore PET, for instance. The graphics I support, the Cross-Lib support, is only tile based. It's not real sprites. But tiles can be used to do softer sprites. So actually I can do softer sprites. And sounds is very limited at the moment. But the advantage of Cross-Lib is that if you have a nice, simple game concept, the game concept can be even complex, but the graphics won't be very complex. You can do it in a way that it's massively multi-target. In the end, once you have written your game, you can just compile it for a given system with a command like this: make name of the target, name of the game. Something like this will compile the chase game, which is one of my games, for the Commodore 64. Something similar for a different game for the ORIC. For the Nintendo NES, you can compile a different game, for instance, like this, and so on. for the Texas Instrument calculator, scientific calculator. You can do it like this. So once you have written your game, the build is trivial. How much time left do I have? I think I have enough time to present some of the games.
Well, we have a bit past, but of course you inherited a bit the delay from before.
I just want to. I don't have too much to say, but I want to present at least one of the games.
If you have one, yes, please do. Antonio is next. If you have any issue with the time, Antonio, please shout. But otherwise, let's. I would say let us focus on this topic now, please, Fabrizio.
No problem. Go ahead.
So I've written a few simple games with Cross-Lib, massively multi-target. I will go through these slides very quickly because I want to show you one game. Cross Chase is the game that is probably the record holder for the number of ports. It's a game that runs on about 200 different systems. It is sort of it's not a clone because I was not copying the concept. It's similar to Gnome Robots, which is a game you find with Linux, and it's a strategy game. Cross Chase is an action, real-time version of that game with some other concepts. Cross Shoot is a different game, but it's a sort of a Robotron clone. Cross Bomber is interesting for it's a horrible concept. It's not my concept. It's a horrible concept because it's about a fighter, a bomber plane who has to destroy buildings. You have to destroy the town. It's a game that was first written for the Commodore PET, and it had a different name. It was called Air Attack. And it was also ported to different Commodore machines in the 80s under a different name. It was called Blitz. For the Commodore VIC-20, for instance, there is a game called Blitz. This is a clone of that game. And then my latest game is Cross Snake, which is my personal reinterpretation of the Snake game and the Nibbler game. So it's about a snake eating stuff, eating apples. So this is what Cross Snake looks like on different systems. On the Commodore VIC-20 here, this is the MSX1. This is what it looks like. This is what it looks like on a Game Boy. I repeat again, this is the same code. You just compile it, you get the same game on all of these systems with different colors, different screen size, and it's done for free automatically by Cross-Lib Magic. This is a short video of the first level of on a Commodore VIC-20. The concept of the game is different than Nibbler and Snake. What it shares with Nibbler, the fact that walls do not kill you. So you have to eat apples in order to complete the level. You can also eat other stuff like the rings, the white rings, to get special powers if you collect enough rings. In order not to die, you don't have to starve. 20 here is your energy. If you do not eat apples too quickly, you will lose energy, and the snake will move faster till you die. You have to, so you die if you hit yourself, as in the old Snake games. You die if your head hits the mines that are moving, and you die if you starve. So by starvation, by hitting yourself, or by hitting with your head the mines. These are the first levels, so they look very easy. But then it gets harder. There will be many mines. There will be up to 6 mines, and there will be more apples to collect. There are many items. There are about 50 secrets to discover in this game, which I don't show in this video. And on this level, you only see the rings and the apples, but there are items that are enabled if you get at least three rings. So you can get special powers. You can freeze the mines and so on. And okay, I have the other games. This is that I can say a few words about them. Cross Chase is the one that is probably ported to the highest number of systems. This is the game on Linux, not my game. This is the original robots game. And this is my version on the Commodore VIC-20. And it also runs on a scientific calculator, as you can see here on the Texas Instrument TI-83, but it also runs on other calculators and some on exotic devices. And I can complete my talk here. That's all. There are other games that have different concepts, and all of them share this idea that you write the code once and you build it for all of them automatically.
I've been playing actually your
and this is the Commodore PET version, the original Air Attack Blitz clone on the Commodore VIC-20, and my version on the Commodore VIC-20. My version actually is using soft sprites, so not just characters. That's all.
Thanks a lot, Fabrizio. I was just saying, I have played, I think once you had put on one of the Facebook groups, you had posted a link to a playable, we could play more or less online, these cross, the snake. Huh?
Yeah,
it was
indeed.
good
You can
fun.
play my games online as well, on different systems.
Maybe you can put the links after, you know, in the chat.
All these links are on my Git. If you just go to my the GitHub page, I have put links for all the 4 games on up to 6 or 7 different computers, including Commodore 64 and the Commodore 264 series as well. And some other systems like MSX and some exotic systems as well. They can be run through some emulators that run on JavaScript.
And I see that in the background, Martin continues to answer a question, and also he has just posted the link to your GitHub. So thanks, Martin, for that. Let's go maybe very quickly over a couple of questions that I see here about the graphics. How are graphics assets represented on text-only platforms such as CBM 610?
For text-only systems, the graphics assets you have to decide. So you have a set of tiles. Tiles are either graphics or mapped to an ASCII character. So, and you can do it per target. Usually, if you really want to, you can just say, on this target, I want tile number 1 to be shown as a $sign, for instance. Or if graphics is enabled on that target, the tile 1 will use the shared graphics. So for tile 1, I have a file where I define what the tile 1 should look like. This is my assets. This is not a C file. This is a data file. When I run the build, a Python script will take the graphics file and convert it into something that the linker can understand. If the system has no graphics, the tile will be interpreted as an ASCII character. On a given game, I decided that tile 1 can be, I can do 2 things. I can either say tile 1 is mapped to the $sign, or I can say tile 1 is mapped on a specific system to a different character. Of course, if you do this, you might have in your code, you might have to have 2 versions. You might have to have an if a game is using, for instance, software sprites, You might have to have a version of the game that is using softer sprites and a version that it's doing something different when there is no softer sprite. Unless if you really want to use softer sprites and you still want to have the same game running on a system that has no graphics. You might have a nice animation instead of a softer sprite, of a smooth sprite, or you might have to do something in the code.
Yeah, for some reason I had to unmute myself. Thanks, Fabrizio. I think looking at the time, I see there's a couple of other questions, but maybe you can also just answer them in the chat. Thanks a lot.
Okay.
And you killed actually my transition, because you said already you will not be able to develop a game like Pig Quest. I was I was going to use that as a kind of transition to Antonio. Okay, so I will just now stop this recording and start a new recording when Antonio is with. Antonio, are you with us?
Yes, can you hear me?
Yes, absolutely. Then now you're going to present us a Pig Quest game. I had the chance to have a look already at the slides. Let's hope you can share that.
Sure. Can you see my screen?
Not yet. We see your name.
Okay.
Wait. On another screen, I
coming?
see. Screen. Yes,
Is
on
it
another
coming?
screen, I see your screen.
Okay.
Yes, absolutely. Yes, go for it. Floor is yours.
Cool. Okay. So yeah, this is a Pig Quest, and thanks for the hook, Fabrizio, and thanks for the opportunity, Sebastian. So we'll see a little bit of an overview of this game and the technical challenges we are currently facing. So it's still not done, but I would say it's probably 60 to 70% complete. It's by far the largest game I've ever developed. So it's taking quite some time. This is the dev team. So Morissette is the game designer and did all the pixeling here and the graphics. This is really his brainchild. So he came up with the concept and put the band together, so to say. He's a professional comic artist and also happens to be an incredible pixel artist, as you can see here. Aldo and Gaetano Chiumo, equally talented musicians. They're doing all the music and sound effects for the game, and I'm basically putting everything together. So what is a Pig Quest? It's basically a platform game, but it's a large one. So it comes in the form of 200 rooms that can be explored. It provides element of non-linear gameplay, so there are puzzles that can be solved in different sequence. It contains secret areas, because why not? And it offers elements of dynamic environment and weather. So to cut a long story short, it might rain at some point, and rain affects the controls. It also contains cinematic cutscenes, plenty of them. From the technical standpoint, I think the most important element is that it's completely done in bitmap mode and non-tile bitmap mode, which makes it very colorful, as you can see, and basically unleashes the pixeling skills of Morissette. But of course, it will offer a lot of challenges, as you will see. The backgrounds are also animated, and there are enemies that are done in bitmap mode. Again, we wanted them to be very colorful, so we wanted to defeat the limitations of the sprite. And you can interact with the environment. There are up to 32 sprites on screen, which is to be expected in a modern Commodore production. And more than 1,000 sprite frames so far, but Morissette's still going at it, so expect them to grow. So it's a graphic mode that is not used very often. And the reason is that, I mean, it's very heavy on the CPU and on the memory. So, basically, when you have a bitmap screen on display, more than half of the big bank is taken by the graphics, and things get worse when you want to move the graphics around. As you know, it takes a lot of CPU time, roughly 5 times that of moving characters, and even more if you want to move the color around. From the point of view of the plus, you can have any 3 colors plus background color on screen. And you don't have any restriction imposed by the card set. So really the screen is a canvas and you can do whatever you want with it. So let's start to take a look at the first challenge, that of the seamless room transition. So when you are dealing with platform games and the character moves from one room to another, there's a bit of a downtime, so to say, where the next room is calculated in memory. This is historically done in a pretty possible way. You can either blank the screen, as you can see in the first example here. So the Commodore 64 can really switch the screen off, basically, and all the calculation happens in the background, and then you bring the screen up again on the new room. Or you can use a second memory buffer, like in the second game here. So the new screen is calculated in the background, and then the 2 memory buffers are, the 2 video buffers are switched. And then you don't see that flash of blackness on screen, so which is more pleasant to the eye, but it comes at the cost of memory. And then there's a third approach. This third example here is Cybernoid 2. It's done in bitmap mode, by the way, but it's tiled, as you can see. And in this case, exactly because you don't have much memory for the bitmap mode itself, let alone using 2 buffers, in this case, I mean, there's no way to put the dust under the carpet. So the composition of the screen happens, and the user just sees it. I mean, these videos are slowed down, of course, to show this even better. What would happen with the Pig Quest? As we say, we don't use styled graphics, which means that every screen is like a bitmap. And of course, it's crunched with LZ77 cruncher, which means that it takes a long time to decode, even with the most optimized decruncher that we put together exactly for this game. And this is a simulation of what the screen would like if we were using the screen blank approach. So bearable probably, but not great. So we took another approach. We call that speculative rendering. So how does it work? When the player is moving the character around, will get close to some specific exit that leads to another room. So what we do is that we use unused CPU resources from the game logic to speculatively build the next room, the closest room, in the background. Then upon entering the room, the 2 buffers are switched and the action resumes. Now you might ask, okay, what happens if you don't enter the room? Well, nothing. Usually it's a waste of time in building the new assets. But then the character will go to another room and the process will start again. So as long as we don't slow down the action screen, this is perfectly acceptable. So seamless room transition, this happening in the background, we said, but how does it work? Because Commodore 64 doesn't have background processes or multi-threading capabilities or such, right? So this is actually the real code from the game. The way you run a game loop, you read the controls, then you draw the hero. As you can see, there's some raster time being used on the left, or the right, sorry. Then you run the artificial intelligence for the other actors on screen. You create the sprite list for them. You update the environment with bitmap animations, update the HUD. It contains things like health score and time left and the likes. And then you finally push all this information that you've calculated to the display list, right? And at this point, you should wait for the next screen to be displayed, which happens at the end of that red area there. So at this point, everything that is being calculated and put into display list is then put on screen, right? So we just use this time here. So what speculative rendering does is that it leaves some headroom first, and then passes that green area there as an input to a function that comes up with an idea of how much of the next room can be rendered using exactly the raster time. And that's exactly what it does. And you can see that upon moving to the next iteration of the loop, a little bit of the next room on the right has been computed. So run this loop many times, and by the time the character reaches the exit on the right, the room will be ready, and it will just go through. Animating large bitmap objects. This is the next challenge and probably the toughest one. This game is done in bitmap mode again, and there are many animations to screen. You can see like the flames here, the puff of smoke coming out on the right, and there are much larger objects, but we didn't want to really spoil the game today. So yeah, but there are large bitmap objects moving on screen. In order to solve this problem, we use two approaches. The first one is called delta coding, and it's not the first time that it's used in games. And the other one is, we call it GFX as a code, and we'll see what this is about. So delta coding, let's take a look at this example. This is the animation, the smoke animation from the second thumbnail in the previous slide. This is really the way bitmap animations are done on any computer. So you have all the frames, and then you just copy them from the memory buffer to the video buffer. In this case, each frame on the Commodore 64 takes 720 bytes. So it's quite large, and there's 13 of them. So to plot to one frame with fairly optimized plotting routine, this animation will take 10,000 CPU cycles. Now, mind you, on a PAL screen, we are talking about 20,000 CPU cycles available to draw one screen. So half of the CPU time would go just to manage this animation. And, we also have to run the game, play the music, etc. So, and there are more animations in the same screen. So this will not be possible normally. Let's see what delta code does. It starts from the realization really that not every pixel in a frame changes, especially if the animations are quite smooth, like those that Moise had put together. So in this case, we transition from frame 5 to 6 of the previous animation. We see that only these pixels on the right have changed. So can we maybe store only the pixels that have changed? Yes, turns out we can do that. Of course, we don't just memorize those pixels, but also we need at some point more memory to specify where the pixel that's changed goes on screen. So some kind of RLE information, right? So let's say we double the amount of information is needed to code a byte, but still, since there's way less than half of the bytes that change in this specific frame, the memory footprint is more than halved. And this also makes speed code possible. In fact, it makes it necessary because we don't have the luxury of just doing copy loops. We need to address the individual pixels. How does it work? So this is a regular copy routine. This is the way the regular animations are done. This is for copying 8 bytes of memory from location X1000 to location X4000. So you have an index register. You read memory from X1000, you put it to X4000, you increment the index register, compare it to 8. So are we done? No, go back to the loop, right? Upon executing this loop, this is the result, and you have to trust me that it takes exactly 121 CPU cycles. So 121 CPU cycles just to copy 8 bytes of memory. And one frame of that animation is 720 bytes, as we say. So it's a lot. So you go to a demo coder and you ask, hey, what can I do about that? We'll say, of course, you do speed code. And they will come back with this trivial solution, but very effective one. So just read bytes one by one, take away the loop logic or minimize it. Usually this kind of block of code goes inside a larger loop. So you either take away the impact of the looping logic from your code, or you minimize it. And in this way, we took away the loop altogether. And this is 16 read or write operations, so it's 64 cycles. So no surprise here. So we almost half the CPU requirement for this copy loop at the cost of memory, of course. Is that enough? Not really, but so that's why we can do a bit better. When dealing with large objects, there will be many values that are repeated in memory, especially 0, for instance, which is like the empty pixel. So when you delete a pixel, you write it 0 somewhere, right? So we thought, let's just get rid of the source memory altogether, and the plotting code becomes the data. So the data is in the code itself. This has two advantages. The first one is that we reduce the number of load operations because we can reuse the same load operation to prepare the data for different store. And at the same time, we are using the immediate addressing code mode instead of the absolute one. So it takes only 2 cycles instead of 4 or 5. And so, yeah, it's a super gain in speed, which takes this down to 38 cycles. On average, the gain is pretty much 8x. So yeah, 8 times faster, because the values are, there's just a subset of them that are used. And this basically brings back to the same CPU time required to move regular car-based graphics. So this makes the bitmap animations possible. And you would ask, what's the impact on memory? Well, not so much, because after crunching, this becomes pretty much comparable, at least in this game from my analysis. Final question that I'm trying to prevent here, who the hell is going to write all this code? Of course, no one does. This is automatically generated by a Python script. So all my assets are translated into this speed code and then assembled into the game. Let's close with another, this is a classic effect. So environmental effects here, just to show that we've also done things in the classic way. So yeah, this is, each raindrop is bright, as simple as that. And also the splashes on the rain, although they interact with the screen. So you can see that the ground here is not perfectly leveled, and the raindrops just splash where they touch. It doesn't look like that, but there are only 20 drops on screen at the same time, and they are randomized, so they are shuffled horizontally, but they're carefully positioned vertically to be multiplexer friendly. So this is really just a demo effect, but it works really well, we believe, because the randomness that is used on the horizontal layer makes it look quite natural. Also, they go down at different angles, as you see, and the trajectory respects the angle. And that's the last effect that I wanted to show. This is our list of contacts, of course, in bitmap mode. So please reach out to us if you want to know a bit more, or please ask any question today.
Thank you, Antonio. Actually, I see there are some questions. There are also suggestions.
Okay.
Coming from so I don't know if that's a name or a pseudonym or nickname, Feezer Wolf. Okay. I guess the first question has been answered. It was, is this on C64? I think maybe it looks so nice that it.
Yeah, I take that as a compliment more than a question. Yes, believe it or not. Actually, if you want, we can also. I mean, yeah, I've had this question a couple of times, but yeah, it's really on C64. You can run it. I mean, so you can see it.
The rest is not really question. It's more like comments. So maybe you can, but I guess they are intended to you, so you can probably look at these in the chat box while I will. I don't see all the questions coming. Yes, maybe very cool approach with your code generator. Would you like to publish it?
Yeah, sure. So I'm not new to showing stuff on GitHub. Most of my previous games are open source. So for sure, I will write this blog post about how this was done when the game is finished, and also publish the code, or at least some noticeable snippets. I mean, this is massive. I mean, usually I publish the full code for things that are manageable, like my Activision ports. And yeah, I mean, there are few. Sorry, I'm very busy here playing. And yeah, they are actually short listings, right? But for this game, probably at least the outstanding parts of code I will definitely publish and share.
Okay, thanks a lot for that. I see some people are saying thanks. I'm going to leave. Please just stay a few minutes. I will now stop the recording here just so that I can mention a bit more things about the upcoming meetings, right? After that, what we can do, because I see still some question, or we can leave the call open if some of you want to exchange information or whatever. But before we close, maybe announcing that the next meeting is now scheduled or foreseen for the 12th of June. Okay, so bring your topics, don't be shy. We will try to do after summer, if the conditions allow, also a physical or presential meeting. The idea is to have at least once per year a presential meeting in a different location in Europe, a location that is easily reachable. Well, of course, we will start probably in Brussels, just because I'm located in Brussels, but I have in mind also capitals usually, right? Like Roma or Madrid. You know, there is this event on Commodore in Madrid as well. That would make sense maybe to combine. We can go north, we can go east, whatever. If you have ideas of locations, live locations, like for example in Belgium, I have in mind in Brussels this Pixel Museum. So if you have any ideas of great locations where we could meet up, just send the info to us. You can of course contact us either via the website or via the Facebook page. If there is demand enough, I think today maximum we are about 40 people, but of course the topics will be also shared on the platform later on, so more people will benefit from it. But if there is demand enough in the future, like having one evening talking only about Amiga or something like that, we can do as well, or just topic specific about programming, C programming, or basic little events. Don't hesitate to reach out to us. We'll just organize that together, I would say. A bit of metrics. We started organizing this one a bit more than 3 months ago, and last time I posted something on the Facebook. We don't get so many likes, but we get like 10,000 views. Out of these 10,000 views, we get the metrics from Facebook. 96% are male people between 43 and 65 years old. So I think when I look at the faces here, we are a bit on the youngest part today. So topics, as I mentioned before, are welcome. Anything that is hardware related, Ultimate, new emulated based machines, modems, whatever hardware where you would be working on, software libraries, these kind of things, magazines. That are being published now, BBS, new terminal, whatever, new SD card readers that you have been testing, or whatever you're working on. Please don't be shy. Come and present this. I want to thank all the speakers for really the quality content that they brought today here and the time they involved into this presentation. Of course, all the participants, don't hesitate again. Please bring your topics. And the pages Commodore 64 gaming news and the Commodore Spain have been also promoting, let's say, the event. I want to thank them for that. And so I'm going to close the live on Facebook and the sharing. But again, as I said, if some of you want to discuss some specific topic, the call is open. This is our space, huh, I would say. So thank you again. And I wish you have a good day, and that we see you again in the next meeting on 12th of June.